Hello everyone. Today I'm gonna introduce programming Raspberry Pi 3 with the language Python and use the GPIO ports, which are the input and output ports of the Raspberry, and control them through some codes of Python. So before I get started, I need to show you the GPIO ports of a Raspberry Pi board and introduce them to you and the address and everything related to them which we may need during the coding. And then we'll go through a experimental project, and then I will show you how to program the Raspberry and how to execute the program and how to define the circuits that you may need for this program, and then we'll show you how these things together will work. Here you can see the final version of Raspberry Pi 3 Model B Plus, and we will use this port for this project that I want to show you later. This board has all the specifications that we may need during the projects. It has a lot of good specifics and good input output ports, and we can run and implement many projects with this board. Here at the top of the board, you can see two lines with different pins on that, and underneath you can see it's written GPIO, which is general purpose input output for the board that we are gonna use. One of the most important things that you have to know is the number of each pin, that when you want to assign each pin to input or output, or when you want to write something or read something from these pins, you have to know what is the number of that specific pin. The numbering starts from this pin, and then we will keep going. The upper one would be number 2, and then the right one would be number 3, and the upper one number 4, and so on to the end of the pins. And the last column will be pin number 39 and 40. From all these 40 pins, at this specific board, we will have access to 26 of them as input and output. Also, some of these pins can have some other hardware functions too that need to be configured through our code. For example, one pin can be configured as a PWM pulse width modulus, which can control a DC motor with making some square wave with different duty cycles and different wavelengths. So you need to be careful that which pin are you gonna use and how to configure that pins for your purpose. And the other 14 number are usually ground or VCC, which is technically 5 volts input voltage, and some other power supply pins that need to be configured or connected to the outsourced power supply and things like that. It should be noticed that all of the 26 ports that use for input and output are by default input pins. In contrast with the Arduino board, which the input-output ports or pins are technically by default as an output. Another important things that you have to know is that all of these 26 pins can have an input of at maximum or 3.3 volts, in contrast with Arduino boards, which are usually 5 volts. Here you can see the schematic and the port names of each pins, which shows you the 26 GPIO ports and the other ports that may be needed, so as a power supply or as an other functional pins. The pins that are assigned with black circles are technically our ground pin, and the pins which are assigned with kind of orange circle is our VCC, which is here 3.3 volt. Also, there are two pins which red circle around them, pins number 2 and 4, which are 5 volt, and can be used for different projects. Pins number 8 and 10 can be used as UART, which are technically serial input and output circuit that we must configure them through our code. Also 24 and 26 can be used as SPI, and also 27 and 28 can be used as I2C ID pins. Here also, if you go through the datasheet of Raspberry and through GPIO section, you will see a table that different numbers are assigned and different functions are assigned to each pin. For example, if I want to show you pin number 7, which is technically in here, the pin number 7, you should find it in the board, but if you want to assign something or read from this pin or write something to this pin, and since we are going to use Python with BCM library, this is number 4, and you have to use number 4 to access to number 7. The same thing for pin number 11, that if you want to write something to this pin through Python, you should use number 17 to have access to this pin. Now you're familiar with the pin numbers and different functions of pins, we can go through an experimental project. In this project, we are gonna assign a pin which is connected to a LED, and then we are gonna turn it on, turn it off, or blinking project by writing some code through Python. So first of all, we need to have its hardware and make the circuit and then see how this circuit's gonna look like. And then we can find the LED is connected to which port or which pin, and then we can have access through Python and then have different functions and different output to that pin and then turn on the LED or make it off. To do this, we are gonna use freezing software to make our board. So as you can see, the default, you will have the breadboard. Then at the search section, I will go through Raspberry, and then I will select Raspberry 3 and drag it onto the board section. Also, I have one LED which I can search it through the ports, and then I can drag it through the board that I want to have that as an output function. As you can see, the longer pin of the LED is anode and the shorter one is cathode, and I place it onto the breadboard. Let's use pin number 7 for this purpose, and then I will go through the Raspberry Pi board. As you can see, by just waiting on each pin, I can see the pin number, and then I can connect this to the appropriate connection to the LED light. As you can see, the longer, which was the anode, is connected to pin number 7. And then the other pin of the LED should be connected to GND or ground of the Raspberry Pi board. For example, pin number 6, which can be used for this purpose. Then I change the color of the wire to black, which can clarify this is connected to ground, and the other one which is connected to pin number 7 that I gonna control the LED lamp. Okay, this is our circuit that we are gonna use this, and then I will save this project as project number 1, and that's all. Now we should write our code within the Raspberry softwares and then insert the code into the Raspberry Pi board. In order to do that, you should first connect your Raspberry to the computer and then open the software type VNC in here in order to have access to the Raspberry Pi board. Now also we have Raspbian software, and also from here we can have different programming languages in here, and we have Python 3 and then I right click it and add a shortcut to this desktop. And now I have access to the Python 3 from here. Now by opening Python 3, the Python shell is open, and now I can start writing the code. Now in order to have access to the GPIO pins of the board, I should add a library to the Python in order to have access to this and then write different codes on this. For this, I should use import function here, so I should write import rp with capital letters I dot GPIO. Remember that all these GPIO should be in capital letters as, and in here I can write any arbitrary names for my library. Now I just write GPIO as the name for my library in here. Now by hitting the enter, this library is easily added to your program. Now if I want to have some information about this library, I can type help and within the two parentheses the arbitrary name that I have already chosen for this library. And then when I hit the enter, you can clearly see all of the information through this library. Here you can find different information about this library, different classes, for example, class PWM, to use pulse width modulation, making on any pins in here, and then different methods that can be used through this class. And clearly see you can find every information within that library and use them within your code. Also here you can find output and input function, and if you see in the description of output function, you can assign a value like 0 and 1 as a digital value or low and high to turn on and off the LED light. Another important function in here is set mode, which here you can define how to gonna interact with the Raspberry Pi. And we are gonna use BCM as the set mode, as I showed you in the datasheet of the Raspberry. If you're gonna use Python as a language, you should select BCM, and the numbers for each pin are there, and then you can find any pin numbers within that mode. Also, setup functions can be used whether if you want to have any pin as an output or input, or if you want to use it as a pull-up function in order to avoid any external noises to the board. Okay, now let's go to writing the code. So first of all, I should use GPIO as the name of the library, and then dot set mode, and it asks me whether if it is board or BCM, and I told you before we have to use BCM for this programming. Next, I should define the pin number that I want to use for my program, and also I should say whether this pin should be as an output or input. So again, GPIO dot set up, and then if I start opening the parentheses, you can see a small help in here that what are the input arguments of this function. For example, directions in and out, which is obvious if you want to use it as an input or output, or the pin number based on BCM actually number that I showed you before, and then everything should be set up. So the first argument is the pin number, and if I go through the circuit that I have already made, we can see which pin is connected to the positive pin of the LED, which is pin number 7. And this pin number is related to GPIO number 4 at Python BCM, so I should write number 4. Then comma GPIO dot out, and then by hitting the enter is already set up. Then by using function output, I can set it on or off for the LED. So I should write GPIO dot output. So the pin number in BCM Python, which is 4, common number 1, which is a high voltage, and that means that the LED should be on. To turn off the LED, I should use the same code, but instead of 1, I should write 0 in here. Now that we could turn on and off the LED light, now I want to write a script in here to blinking the LED. By clicking on Ctrl and L, a new script will be open, and I can write everything to that and then save it and then run the program to the Raspberry. First, I can save the file anywhere by clicking Ctrl S and then save it as P1 for later use. So again, from the start, I should import the library of GPIO. And to make a blinking LED, I should also import a time library because the time in here is important. So import time, can easily attach the library of time to the program. So again, the set mode should be set as BCM. Then I should use setup method to define which pin I'm gonna use. So that should be pin number 7, which in Python BCM is number 4, and then define this pin as an output pin. To make an infinite loop for the blinking, I can use a loop while in here, and while 1, that means that an infinite loop. So I can output, so I can use output function and turn the LED on. Then I can use time.sleep as a pause. So here I can use time.sleep 0.5, which is half a second in here. Also, I can use print function to show that the LED is on. It's better to have it before the time.sleep. And also I can have these 3 lines again and then turn off the LED and then pause for half a second and if I hit F5, the program will run. As you can see, all of the information is LED on because at the second part of the program, which I wanted to turn off the LED, I didn't change that part in the print. So I should change the print turn LED on to LED off so you can clearly see in the Python that what's happening there. Now you can clearly see that the LED is on and off, and between each on and off would be half a second delay. We can also change the delay time to 1 second and see now the timing is increased. And since I had an infinite loop in here, so the program will be repeated infinitely. And in order to stop the program, I should hit Control and C to stop the program and getting exit through that. Now we can go through another script in here. So I just copied the first 4 lines to get everything set up in here. And then I want to use for loop to make this blinking project. So in here I should write for x in range function, and the range is the number of the repetition of the program that's gonna be run in here. Here from 0 to 5, that's gonna be 5 repetition from 0, 1, 2, 3, and 4. So again, I should write GPIO.output 4 and 1 to turn this on, and then I can write print to show this to me that LED is on, and then I can make a delay with the function time.sleep for 0.5 second, and then again I can copy and paste this and then change the output 1 to 0, and then LED on, LED off, and then I can save this. And also by hitting F5, I can have the program running through the board. And as you can see, after 5 times repetition, the program is exit and then stopped. So by changing the range function arguments, we can increase or decrease the number of repetition. Okay, now our first project, which was turning on and off an LED and blinking the LED, was easily implemented and executed. And you can improve this program and you can add anything to this program and see what will happen next. Okay, I hope you enjoy. Have a good time.